¿Sí? ¿Sí o no?
So can we take this session sitting down? Can you please take a seat? So we will start with the vision statements, which we didn't have time for this morning. So I can see Leon Corving there, Matthias, University di Bologna, Adriana, if you're here. Great. Leon, over to you. So the rapid business, hopefully, or are they necessarily in order? Maybe if we do them in order, we'll see. You have slides?
Yeah, I have slides, yeah.
So Leon Corving slides, please.
No, this is a setup.
Maybe Adriana first.
Yeah.
Since if people doing it can come, then we'll do it in the order of slides. That would be less complicated. So yes, back to the slide we had.
I don't know if it's working.
Maybe
maybe they can change it. It's only 2 slides. I try to keep it brief. Perfect. So, hi to all of you. Thank you again for the opportunity to share this time the Zetaqua Water Technology Center vision on nutrient recovery topic, in this case. So I will start where I start also yesterday in my presentation about Life Enriched project. So we want to move forward towards biofactories instead of wastewater treatment plants, and make nutrient recovery instead of nutrient removal, and also incorporate sustainable fertilizers to the agricultural sector. So for that, we think that several things are needed. So the first would be technical viability, different technologies to solve different needs, and also to produce efficient fertilizer products that they can be used by the fertilizer industry. In this sense, we already have several technologies that we saw these days that we are about to implement and go industrial scale. And also we can produce different type of useful fertilizer materials. So I think we are doing well in this part. Also, attractive investment is needed. So especially when we want to start to implement at full scale and industrializing these new technologies, is important that, in this case, wastewater treatment plants want to implement the technology and go for it, and also that they can make somehow profit of these products that they are producing. So funding and economic incentives are also important tools to make these inversions attractive. So we think that there's work to do in this part. And finally, the end user engagement. It's critical for these technologies can be implemented and the produced fertilizer products can be used by the farmers and also accepted by the consumers, or even demanded by the consumers, because the global population are willing to use and want this sustainable agriculture and sustainable food. So in this sense, I would like to highlight that there is important in order to make this end user engagement to work on safety awareness. We already have seen that we have safe fertilizer products that comes from phosphorus and nitrogen recovering, but it's important that the end user, that the farmers know that. So we have to work in that way from the technology centers and also from other parts of the value chain. And also it's important as supportive policy making, because it can show that the products are safe, but also it can help, it can push for these new technologies implementation in different ways. I will not go into detail, but as an example, the new fertilizer regulation product that allows the use of different recovered materials from phosphorus recovered. So, let's really quickly, how Zetaqua can contribute. Zetaqua is a public-private collaboration model that provides initiatives for sustainable and efficient water cycles. So we especially work on development of new technologies and have close-to-market solutions, but also really important, and just I finish with that, we also want to develop new value chains and bring together the different key actors along the value chain so they are in contact and the needs are listened. And we do this around the different projects that we coordinate and participate on. So thank you so much, and don't hesitate to ask any questions or reach out for potential explore collaborations. Thank you.
Then we have to go to the next slides.
Yeah, just go to the next ones. Hopefully,
Maybe.
the right thing will work.
Now we need the next presentation. Yes, that's the one. Yes. Hello, so my name is Leon Korving. I'm working for WETSUS. WETSUS is a Dutch research institute for water technology, and we act as a sort of an intermediate between academia and companies. So we work with more than 106 companies that are member of our WETSUS network. And on the other side, we work with 16 different universities and 57 professors working on 60 PhD projects. And what makes WETSUS special, I think, is that we have these PhD projects physically in our building in WETSUS. So we have PhD students working from all different universities in one building, therefore creating also a lot of knowledge exchange between universities. I'll share with you a slide on what we think, maybe first on what we think is important in doing research, if it changes. Yeah, so of course we are a technology institute, so we still think we need better technology. I think a lot of technologies on phosphorus recovery have been developed, but if we make the comparison to mobile phones, I think we're at the Nokia level now, and I think we should get to the iPhone levels. And for that, we still need to do a lot of further research. Of course, we always need to look at why we need the technologies, and obviously we need to understand the market drivers and things like that. But we should, I would like to warn that that does not mean that we should only optimize existing technologies. Therefore, we should always also work on the ideation projects, so be creative in getting new technologies, and also on foundation research, so really understanding the fundamentals of science. So we had a very nice session on iron and phosphorus interactions this morning, and we learned a lot about what we do not know, actually. So I think that's also interesting, and the more we know, the better we can tune our technologies. So that's about the technology part. But technology is not the only solution, and I think we are very happy that we are now cooperating in an ITN network called RECAP, where we are not only looking at technology, but we also have PhD students from the social science. And we had a conference 2 weeks ago where we learned a lot also from the social science people and to get these interactions. And on the other hand, we can educate the social science people on what technology can do and not do. So I think this interaction is really important. And when we look at what we do at WETSUS, if you want to connect to us, we have, let's say, 3 main lines of research. So we look into vivinite in various aspects, both in sewage sludge, but we're also starting to look at vivinite in surface water and lake sediments. The other main research line is looking at iron-based adsorption to go to ultra-low phosphate levels in surface water. And the third line is that we are looking at calcium phosphate. For instance, we are looking at biocrystallization in manure in combination with digestion. And we're also looking at a new technology called electrochemical calcium phosphate precipitation. So if you're interested in that, you can connect to us and see how we can collaborate. Thank you.
Good afternoon. My name is Kari Ylivainio, and I come from Natural Resources Institute Finland, and I'm coordinating the Lex for Bio project and now presenting the vision of our project regarding to phosphorus research. As you know, phosphorus is a finite natural resource, and at some point the scarcity of phosphorus will have an impact on food production. Whether it will be next 20 years or 100 years, we will see. However, at the same time, we have a vast amount of nutrient-rich side streams that contains lots of phosphorus, but those are inefficiently utilized in agriculture as a phosphorus fertilizers. One of the reasons are that its transportability is quite low, contains lots of water, or then there is a lot of harmful substances that hinders their use as a fertilizers. Therefore, we need to transform them into bio-based fertilizers that are more acceptable among farmers and consumers. But when producing these fertilizers, we need to ensure that we can produce good crops with these fertilizers and also ensure the quality of the harvested crop. And also human health needs to be ensured, and also to minimize losses to the environment. So we need to develop better tools to estimate phosphorus fertilization requirement in various climatic and soil conditions across Europe. Here is just a map to show the variation in soluble phosphorus concentration in agricultural soils in Europe. As you can see, there exists great variation in phosphorus content. And as compared to mineral fertilizers, these bio-based fertilizers, they have a very different chemical compositions, so they might have effect on these, of course, availability and also to nutrient losses in these different places in Europe. But in our vision, we are considering that in the future, these nutrient-rich side streams are converted into bio-based fertilizers, and they are efficiently utilized across Europe, and they can be used for replacing mineral phosphorus fertilizers. Thank you.
Myself from September. We'll report on the first session from this morning, new and recycled fertilizers.
Yes, so I'll try to be quick because my plane will not wait for me, I think. So we had very interesting insights into many aspects regarding phosphorus, new phosphorus fertilizers. So Anna Robel started highlighting how pot standardization is needed when trying to understand phosphorus availability from different phosphorus fertilizers, because we often forget to consider many aspects as the time effect, so the slow release of phosphorus from these fertilizers, the dose effect, as different doses can lead to different responses, and also the substrate effect. So to understand all of these effects, a PhD student at their institute performed the first pot experiment to see the dose time effect with different phosphorus fertilizers. And she highlighted that the optimal amount of fertilizers was 35 milligrams of phosphorus per pot, and that the optimal release was achieved after 4 months, while the maximum release was achieved after 7 months. Then in a second experiment, they compared different substrates, as also substrate has a great importance, with the best one being slightly acidic sand. So this highlights the importance of a comprehensive approach when speaking about phosphorus availability from phosphorus fertilizers. Then the second speech by Kenzai introduced us to the world of actinobacteria, which can benefit plant growth in a multiple of ways, for example, by solubilizing phosphorus from rock phosphate, but also releasing beneficial substances and protecting plants from infection. She tested different actinobacteria strains with different rock phosphates, and she identified 4 strains that perform better than the others, especially at promoting root growth. So these could be good candidates for biofertilizers, also in terms of potassium that she made some tests on too. We remain in the microbial world with a presentation from Wissel that showed a workflow, a very nice workflow to select phosphorus solubilizing bacteria, starting from in vitro screening, moving to in-soil screening, to in-plant screening to get the consortia construction. She divided the phosphorus solubilizing bacteria into different groups with low, high, and medium capacity, and one interesting result was that even the low phosphorus solubilizing bacteria may have a positive role in promoting plant growth, for example, by favoring the root traits. So the main outcomes of these 2 last presentations were that exploiting microbial functional traits related to phosphorus solubility is an efficient strategy to increase the rock phosphate solubility, but of course it requires a lot of previous work to screen all these bacteria. Then we left science for 10 minutes with Egor and Sergio, and they reported on a survey on farmers' perception to use and willingness to pay for biofertilizers in the EU. This is a point that came out very often last days. Targets were farmer and agricultural advisor across the EU, and the survey was launched in January. As for the intention to use, it was positively affected by the attitude and perception of benefit and low risk, while it was negatively affected by the provided knowledge on the fertilizers, which was something that raised a couple of questions in the audience because of opposite results that were obtained in previous investigations. And as for the willingness to pay, one take-home message is to distinguish the marketing activity that address livestock-intensive region and the livestock non-intensive regions. Then jumping back into silence, Caroline Monica reported some results on the carbon fertilizers project, which is aimed at producing carbon-rich phosphorus and nitrogen fertilizers from manure and fermentation residues. She showed us the result from a pot experiment in which different types of char fertilizers were used. And these fertilizers basically can provide the same fertilizer activity as a commercial one, a normal one, but very importantly, they can cause the lowest nitrate leaching, so very important for the environment, and also the lowest N2O emission rate. So they are very important products that have multiple roles in soil. And finally, Muzumi reported on the screening of potato varieties for finding those with a high phosphorus uptake efficiency, so as to identify the genes that are involved and to use them as marker. So she started from 183 accessions, which were compared to 17 modern cultivars, and that were treated with high and low PE conditions. So she restricted the circle time by time, and then she highlighted 9 groups of potato genotypes, and she left us with the hope of having found very interesting genotypes to test further in the future. So that's all. Thank you very much.
Thank you very much. Is Jakob Sandner there? Because it would be good to read. No. So is the rapporteur of the phosphorus interactions in soils? Is there a rapporteur? Okay, can we group it because it fits in? Yeah, okay. No, cool. I'm sure you'll do a good job. If it fits well with the session we've just discussed, then we'll have questions on the 2 sessions.
Yes. So on this session we had 5 presentations. We started with modeling in an Australian study where phosphorus, nitrogen, and phosphorus dynamics were estimated by using models of nutrient dynamics in soils. And it was shown that these can be utilized in predicting changes soil nutrient status in soils. But I suppose this is still an area that needs more work to be done. Then 2 presentations were presenting fertilization strategies in crop production. Other one was from Belgium, another one from Czech Republic. In Belgium, the aim was to mine soil with crops which had a very high phosphorus concentration, and they had a 7-year field trial. And during this year, there was no observed any yield decrease, even the phosphorus fertilization was totally omitted. And the phosphorus balance during this 7-year trial was minus 280 kilos, and they were still not seeing any decrease in easily soluble phosphorus fraction in that soil. And also in soil organic carbon content, there wasn't any significant effect. On a yearly basis, the phosphorus removal was 30 to 40 kilograms per hectare, so it was roughly at the most 1% of the total PE. Whereas in this field trial in Czech Republic, the trial had lasted for 21 years, and there was a clear decrease in soil phosphorus status during this trial period, and also they were seeing effect on crop productivity as well. So I suppose these trials just show that we need to balance this phosphorus application in order to keep it in a safe level, because it seems to be quite difficult to decrease if we increase it too high level. And then two presentation was dealing with phosphorus reactions in soils and how this phosphorus is moving between different pools in soils after applying either bio-based fertilizers or mineral fertilizers, and how these phosphorus concentration varies in these different pools. These both PPFs and mineral phosphorus fertilizers increase these different phosphorus pools, but phosphorus release from bio-based fertilizers was lower as compared to mineral fertilizers. Then, on my opinion, the most scientific presentation was dealing with organic matter effect on phosphorus solubility in soil. I think in many of us it was a very scientific presentation, but on overall it showed that organic matter competes with phosphorus on these phosphorus adsorption sites and made us increase phosphorus solubility in soil. But this effect may be different in saline or non-saline soils, and depending on the availability of sodium and calcium in soil. Because these cationic may flocculate clay particles, and this may have an effect on the availability of these plus and minus charges on soil particles, and this might have an effect on then phosphorus adsorption in soil. I hope that I explained that correctly. Please correct me if I was saying something wrong. Thanks.
Thank you very much. So I propose if there's any questions on those two plenaries or on the vision statements, the plenaries, parallel sessions, or on the vision statements that came before them, or anyone who was at those parallel sessions and feels that there was information that wasn't fully reported or would like to comment on that. Any comments? Okay. If not, then yes, we'll move on to Bengt. So reporting on the session on iron-phosphorus interactions.
All right, thank you so much. We had this iron phosphate session, and there were a lot of people interested in this fairly narrow topic, I must say. We had 7 presentations. Luckily enough, we only had 7 because I had 1 page left in my notebook to do a summary. So it was a lot of discussion about iron chemistry, but first of all, I took a note on one of the quotes on one of the presentations saying that the biogeochemical cycle of phosphorus is closely coupled with the one of iron. So certainly the link between iron and phosphorus is very much indeed necessary to understand better. So we covered both very fundamental parts of iron to phosphorus chemistry, as well as a little bit more practical experience. And we covered areas of phosphorus removal from different kinds of stream, from wastewater, from activated sludge, from sediments, from runoff, from agriculture, and so on. And then we try to understand a bit on how to apply it later on. Some learnings from the seminar: ferric phosphate, was surprisingly soluble in Olson P compared with other recycled products in one study. Another learning from that study was that it is very important to see that the microbiology is very important for the availability of the phosphorus and the nutrients in the soil. And also, talking about bioavailability, you can also do bioacidification as a pre-work to further recover the phosphorus more easily afterwards. So that's another learning. What else? Yeah, we had this. I said that the ferric phosphate was easily more soluble than the others. And this is a little bit contradictory to another learning, which was that saying that iron phosphate, ferrous phosphate, when that was oxidized, it was a little bit less water soluble than the vivianite or the ferrous phosphate alone. Then there were discussions more on the phosphorus is precipitated, how it's adsorbed, and it's of course influenced by very many different parameters, for instance the molar ratio between iron and phosphorus, the phosphorus concentrations, and the aging is also very important on how the available and how well you can remove phosphates in interaction with iron. And then a final learning here was that we need to learn more about quantifying and analyzing, because this chemistry, even though it's iron and phosphate, which sounds fairly simple chemistry, it is much more complex than you might think first. So we have a call for action here that we still need to learn more about this iron phosphate chemistry so we can better explain the results we have and also learn more on how to further apply this know-how. Thank you.
So I'd like to have the report from the dairy workshop, Jan-Philippe. No, somebody else. Tell me who. I don't mind. Whoever. Who? And then we'll have questions on those two workshops. So the report on nutrient recovery from dairy industry processing.
Thank you very much. First of all, I'm Ipan Hidayat, not Jean-Philippe. I'm a PhD student from Beta Technological Center, Spain. So today I'll report about the breaking session 3. The theme of this is nutrient recovery from dairy processing wastewater. So the sessions is actually coordinated by REFLOW. This project, REFLOW, is a project under Mary Skłodowska-Curie Action, H2020. And in this session, we had 6 amazing speakers, and with a different focus, you know. And this focus is compiled with the REFLOW work packages. The things that the focus is first is technological development and optimizations. And the second one is the agronomic test. And the last but not the least is about the sustainability. Let's move on. The first speaker was stated by Pablo Matribinder from Beta Technological Center. So he started the speech about how the dairy processing cycles from producing the dairy products into producing the wastewater. So he introduced the EBPR, which is enhanced biological phosphorus removal. So in this technology, so you're not only producing one product, but multiple products. So in this technology, you can produce BBFs, bio-based fertilizers, soil improvers, biofuels, and bioplastics. So as I said before, not only one product that you can produce, but only more than one is multiple. So this actually very promoting the circular economy frameworks. So for your information, that in EBPR process, you have 3 different stages, which is anaerobic phases, aerobic phases, and anoxis phase. So in anaerobic phase, you can produce energy-rich compound, And then in aerobic phase, you can produce phosphorus-rich sludge, which is very good for bio-based fertilizers. So now it depends on which goals are you in. If you want to produce energy-rich compound, you have to stop the process in anaerobic phase. And in the product characterizations, the ABPR sludge is compiled with the ISO standard and also compiled with the product function categories, which is VFCs under fertilizer regulations. And the aerobic sludge, which has high nitrogen and phosphorus content. The take-home message that's very important that we have to note it down here is that, as I say, that this starting point of the dairy processing wastewater, we can produce safe and economic products for bio-based fertilizers. However, now that this dairy processing wastewater is not compiled with any CMC under regulation, fertilizer regulation. So the second speaker is delivered by Marzena Kompitska. Thank you. And I have a lot of notes because it's very interesting. So the first thing is that she explained about the challenges of the sludge production in islands. And later on, she introduced HTC, which is hydrothermal carbonizations. The results from HTC is actually they have liquid fraction in liquid, they more produce liquid fractions, but less total phosphorus content, which is 0.5. And they produce hydrochar with high total phosphorus content, which is 97%. The third speaker, Wanshan Shi, from Tagash Islands, she mostly developing the calculators. The aim of developing this calculator is actually to help farmers to define safe application ratio of nutrient in the farm. So she successfully introduced or developed this calculator. And how to do that? If you applied all the soil index system, heavy metal concentration from EU database, so in the end you can have the result of maximum spreading rate in tons hectare per year, and also you can have a maximum permissible spreading in tons hectare per year. The fourth speaker, I'm sorry, a little bit late, Yihai Hu from Aarhus University. He's mostly focusing on emissions from how, when you apply the fertilizers, and then we are not maybe taking into account how emission that you produce from your fertilizers. So the results show that the application of phosphorus biofertilizer in the field is not really increasing the greenhouse gas emissions. And the thing is that now the hydrochar that he actually researching could limit the crop yield. Probably this because of nitrogen content is low in the products. And then the further toxicity test will be conducted later. The fifth speaker is Sven Sommers. So he actually researching about how they decrease or reduce the greenhouse gas emissions from HTC, which is hydrothermal carbonizations. And he found out that by introducing HTC, it can reduce the cost of management up to 0.12 million Denmark kron. And the last but not the least is Marta Bejat, the sixth speaker from Chalmers University, Sweden. And she researched about the LCA-LCC. The problem now that we face of the LCA is like we lacked lack of information regarding the phosphorus recovery in dairy wastewater. So she did the meta-analysis in order to cope this the lack of information. She applied different scenarios of in the case of a reflow that strophied precipitation with two different scenarios, and she found out that to produce low energy consumption and low GHG emissions, so you can have the first scenario, which is strophied, that we have input material from anaerobic membrane bioreactor coupled with freeze concentration. That's it. Thank you very much.
Thank you very much. I'm sorry about speeding you up. Are there any questions on those two sessions on recovery from dairy and on iron and phosphorus? Or does no one dare open again the Pandora's box of iron phosphorus chemistry? If not, we'll move on to the last two sessions. So for regional policies, it's myself reporting because Natalie was struck by an unusual version of the aircraft delay where it left early. So she's gone. So can I have my slides? So the session on regional policies, we had presentations addressing nutrient management in different waste streams. So in fact covering basically the main waste streams in which nutrients are available. Presentations from across Europe, Germany, Ireland, the Netherlands, Poland, and in fact the 4 Visegrad countries, and there'll be a quiz later to see who knows the answer of which those countries are. The people who are in the session are not allowed to participate. Finland, and a international presentation, and maybe just to take a figure out of one of the presentations, the total potential in these secondary streams for nutrient recovery of 1.9 million tons of phosphorus, 11 million tons of nitrogen. That's what we've been here talking about much of the time for the last 3 days. Next slide, maybe I can do it. Yes. So I've split the presentations into 2 different themes. There were 3 presentations which were largely about assessing phosphorus flows, and we know, and our platform ESPP has been very pushing at different times this need to have the knowledge of the phosphorus flows, because if you don't know how much of the stuff is moving about, you don't know what the potential is for managing it better or recovering it. So one presentation from AMFOR project in the Ruhr area of Germany, looking at the potential to recover phosphorus under the German legislation, which has specific requirements about recovering phosphorus from sewage sludge. And that means looking at distance of transport to incinerators, sludge quality, because that clearly defines whether you have to recover or not under the German regulation, and achieving the obligations under the regulation, and different technologies which have different requirements in effect for transport. The ABC project in 2 counties of Ireland, which I will not attempt to pronounce because I won't do it properly, looking at manure management, both for resource recovery and for energy valorization, and a Lex for Bio presentation assessing the regional nitrogen and phosphorus flows in bio-wastes across Europe by regions. 2 other presentations looking at regional policies, one in the Visegrad countries, so the answer is there. It's Poland, Hungary, the Czech Republic, and Slovakia, for those who've been desperately trying to find it on your mobile phone in order to win the prize. And one from Netherlands, talking about how to reach a national objective of circular resources from water and sewage. And some of the takeaways which I brought out of that session as rapporteur. Firstly, there are very different drivers why we should want to bother to recover nutrients, apart from the fact that it's a morally nice idea. Firstly, legislation, which obviously, when it's applicable, obliges to do it. Secondly, greenhouse emissions reduction and a strong interest in biogas, and often nutrient recovery can be a synergy with that. And then public policy, not obligation, but public policy inciting, for instance, regions taking the initiative, or social governance reporting, pushing people, and maybe in the EU taxonomy that will push in that direction as well. The need for data on flows, but also on the quality of each flow, so how much nutrient is there, what contaminants, and very important on spatial distribution, local hotspots, where is it, and the difficulty to find that information given that the Eurostat statistics and the NUTS regions don't really either provide the information you want, not at the right scale. The importance of looking at sludge quality, which fits in with the question of quality, phosphorus content, contaminants, and that influences the choices of technology and influences planning. The need to engage with stakeholders, and I think that's a theme which has been present in very many presentations, in order to ensure safety, which is, of course, the fundamental thing. Operational reliance, stakeholders don't want a centralized system, which if it stops means suddenly their manure piles up. produce a product which responds to user needs and to user demand. And finally, the need for a holistic approach, looking at energy, different materials, and including social and economic factors. So I'll now go back to my role as moderator and change microphone. So now a presentation from the new technology session from Francesco.
Yeah, thank you very much, Chris. Well, this session was about the new technologies, but actually the TRL was quite high. It was 5 to 7 probably in some cases. So we were discussing about pilot to demo, where lower TRL was for some specific steps of the process. Well, I tried to schematize what we heard by source. So, well, let's start from the geographic distribution. We had the northeast session because presentations were from Germany, Belgium, Sweden, Finland, so nothing from Italy, Spain, France. That was quite strange. I mean, maybe it was a case. And the main source that was analyzed was still wastewater and sewage sludge. But we had also a very interesting presentation, for example, for phosphorus management in the feed industry about cereal byproduct. That was very interesting because it was starting from the German P-flows, analyzing what is not usually quite widespread in literature. We had a presentation about the steel slag and agricultural digestate. Well, in terms of technologies, a lot of attention is on thermochemical processes. In terms of optimization of temperature, optimization of energy efficiency, but also, well, chemical physical processes, optimization of leaching systems was discussed a lot. But a lot of questions, actually Leon was asking always questions about economics, because economics were missing. That's true. So in the majority of the presentations, but sometimes in the backup slides there were some features about economics. So high TRL, missing economics, and what I noticed also, a sensitivity analysis on the initial concentration of phosphorus was missing. So for example, in Italy we have much less concentration in sewage sludge, and a lot of these studies probably have to be highly revised for some scenarios. So this is very interesting to start from the beginning, how much phosphorus we have when we start, and then we move to optimization. So I would say that TRL high from a technology point of view, but from the social readiness level, legal readiness level, there is a lot of work going on, probably at more lower scale or level. And the attention was also on membrane processes. It was very interesting to see how phosphorus recovery is part of the biorefinery approach. So is a preliminary treatment before nitrogen recovery, is a treatment that then can boost biogas production. So the biorefinery approach was always taken into account. Of course, in this period, there was high focus on energy efficiency. And this was something that was not considered probably when the project was written. Now, again, a sensitivity analysis on the energy cost would be very beneficial to understand how we are resilient to changes. And the quality of phosphorus recovered, different forms of phosphorus were recovered, and also as a future perspective, a business case was presented. So again, this was on the horizon, but it was not part of the study that was presented. And well, the impact on regional flows was presented, especially with concern to some new fields. A lot of discussion was about the kind of chemicals, the cost of chemicals, and some features about the environmental footprint of using these or that chemicals. It was very interesting to see a presentation about centralized and decentralized approach. In particular from Finland, we had an example of container-based solution that is treating wastewater to recover cellulosic sludge, and then hydrothermal carbonization, then applying membrane chemical physical technologies for nutrient recovery. So a new concept about decentralized systems. And we had two kind of, let's say, scenarios. One is developing the technologies for different sources, and one is optimizing a flow chart for a single source. So these two were different approaches, finally. And well, as a general conclusion, an important added value is how to manage sludge and finally having phosphorus as added value. So again, the focus on thermochemical processes is highly of importance, and still the end of waste was addressed, analyzing the contaminants in final product, but it's something that has to be more and more investigated. Thank you.
Thank you, Francesco. Are there any questions to those two sessions or people who are at the sessions? Yours, Maria.
Couple of comments. First one is about your session about the regional policies. I wanted to make the point yesterday, but it was when all the people that is working with the balances and the statistics. One thing that is happening for sure in Spain and probably in other southern countries in Europe is the importance of the water reuse. And I know, for example, that there is software for the farmers calculating what is the additional nutrients they have to put in the water because they were already nitrogen and phosphorus in natural water, but there is also a big use sometimes in garden and park uses or golf courses. But this is a thing that has to be taken into account because it's part of the picture and a part of the thing. And the second comment was about what? I don't remember.
So thank you. If it comes back to you, maybe there'll be time. So water reuse, yes, and indeed the EU water reuse regulation or directive or whatever it is has recently been updated. So that is also taken into account at the European level and is indeed, and one of the presentations, the one from the Netherlands, Kirst, did indeed look at the whole cycle, including water. But yes, it's clearly a way of recycling both the water and the nutrients, and again, with the need to ensure safety and quality criteria, which are covered, as I understand it, by the EU regulation, although it's not. I admit it's not something we've been following closely. Any other questions on those two sessions? Okay, so we have... He's remembered his second question. It better be worth it, or you're going to be really embarrassed.
This is a question for the leaders and for the experts. No, there is a legislation in preparation in Spain, in the Agriculture Ministry, that is the real control for the farmers about the fertilization. So they have to report everything. I don't know what is the European context for this. Is it going to be... I know other countries probably, I remember Denmark, for example, no? They already control everything. But I don't know. But this is very important for the farmers, but also because, for example, for sludge, it's a big restriction because you cannot, sludge, you have a NPK balance, so the NPK balance is at all the balance for the crops. So it reduces the phosphorus is the limit, so I think it's not applicable to make 5 tons or 10 tons per hectare sludge application. So if this decree is going to be applied, and it's fair that this is going to be applied.
So this is the FAST tool, as it was called, yes?
Yeah, it is prepared. I don't know when. My question is also for you to say if it is happening in the other countries, and this will be a European umbrella for this it will be in the IMAP theoretically, but IMAP is an action plan, it's not a regulation. It was an affirmation and also a question for other countries, for the experts.
Any comment on that? The obligation for farm nutrient balance monitoring is included in the new Common Agricultural Policy, not as a condition for receiving subsidies, which is what some may have wished but didn't get, but it's included in the Farm Advisory Service, whatever that means. So logically it will be in member states' implementation plans for the Common Agricultural Policy. It does indeed sound like something you would expect every farm to manage the nutrients going in and the nutrients well, to monitor the nutrients going in and the nutrients coming out. But in fact, not all farms do it in many countries. So that will be improved, hopefully, under the new Common Agricultural Policy. Okay, any other comments or questions? Right, so we have three things left. We have Matthias, who got axed because he was unfortunately not here at the wrong time, because it was the wrong time. It was my fault for changing the program, but I changed the program because people had to leave because their aeroplane changed, which has been going on for the last 3 days, but it makes life more interesting. It would be really dull if you followed the program. So that's the first thing. The second thing is Katja Klasink from DG Research, who we know well, who's been at previous PERMs, unfortunately intended to be here and has health problems, so rather than bringing us whatever it is she has, she's kept it in Brussels. But that means, so we do have a recorded presentation from her. And then the third thing is there are some final announcements about the social activities this evening for the young people, and I'm hoping that young is quite flexible, personally. And also, as a final announcement, people who have posters, if they are not taken down off the walls, they will be blown up by the security people and disposed of. And similarly, for people who've left luggage at the reception desk after 5 o'clock, it will be given to somebody else or just left in a heap somewhere. So do take your things away. Right, so Matthias, and then the presentation from Katja, and then I will open it for general comments about the whole of the 3 days, the meaning of life, or anything else you wish to say.
So, yeah, sorry for being late. There was a misunderstanding. I thought the rapporteurs were first and we were after that. Well, okay. So I'm completely confused. I'll make it short, really short. I chose to tell some more things than Flash was just at our institute, sanitary engineering. We do a lot of things. With phosphorus, we've started some 20 years ago. Developing first new technologies. The best known will be the Stuttgart process, because it has been implied quite big in Offenburg, close to between Freiburg and Baden-Baden. Ran there for about 5 or 6 years in a part stream of sludge liquor. Quite successful, but too expensive, and so they stopped. Basically, there's a lot of experience from that still. Another interesting thing also, Superphos, special development to solidify somehow, to absorb the phosphorus on paramagnetic particles and then remove. Now I know that they are already present in sewage sludge as paramagnetic particles, so we don't have to to dissolve this. I learned today and yesterday. Thanks for this. I will forward to my colleagues. We had another project that was called Recophos, which is basically the forerunner of the current project Flashphos, so I don't say so much of that. It was based on ash. We want to go for sewage sludge, because this is the form in which we have the phosphorus on the sewage treatment plants more in Europe than ash, which is mostly in Central Europe. Today, no. We try to embed our developments more in holistic approaches, so in bigger projects which look at the situation all around. So embedding this technology in, for example, like in this Twist Plus project, whatever this meant, transition paths for water infrastructure systems, together with a lot of other aspects than the technological aspects, so social aspect, political aspect, legal aspect, implication, acceptance with big model experiments. Also, we often combine phosphorus or nutrient recovery. We often do nutrient recovery, so both nitrogen and phosphorus, with micropollutants removal and these things. So that's quite interesting because they're often linked. Yeah? And we have another project called RUN, Rural Urban Nutrient Partnerships, focusing a lot on the connection between cities and the countryside, where the nutrients are needed, and cities where the nutrients are made. Also with technological further developments and implication and citizen. And then we have the same with FlashForce, which may not be have been told so in detail. FlashForce is also quite holistic approach where we look at much more than the pure technical development or demonstration. We look a lot on ecological, economical, and also social impact. So about 50% of our project deals with that. Yeah? So we want to go to the market, and we want to be sure that the market does not spit us out again. And so my final message, or that's our vision for the future in nutrient recycling. I think many of you will agree and also do the same. We want to have the nutrients where they are needed by combining technology, implication with sound resources management, and also social, ecological, economic impacts, so that we know where we are before we go to the market. Thank you for your attendance.
Thank you very much. So now if we can have the recorded message from Katja Klasink, which becomes kind of a final closing message from DG Research.
My name is Katja. I am here today with you only virtually, sorry for that. But I'm going to give you an overview of our activities in Horizon Europe at the European Commission on nutrient activities. So let me quickly share my screen. All right. So, as I already said, I'm going to give you an overview of the R&I activities on nitrogen and phosphorus in Horizon Europe today. For those of you who are not familiar with Horizon Europe, here is the structure. Horizon Europe is composed of 3 pillars. And in Pillar 2, we have 6 clusters, of which the cluster food, bioeconomy, natural resources, agriculture and environment, which is where we have located our nutrients activities. Cluster 6, as I already said, is on food, bioeconomy, natural resources, agriculture and environment, and works in different, in so-called intervention areas, as you can see on environmental observation, biodiversity, agriculture, seas, oceans, food systems, bio-based innovation and circular systems. And the nutrients activities belong to the intervention area 7 in circular systems. With these activities, we are looking to contribute to several long-term impacts of Cluster 6. There is, as you can see, highlighted in green, climate neutrality and adaptation to climate change, preservation and restoration of biodiversity and ecosystems, sustainable and circular management and use of natural resources, and food and nutrition security for all within planetary boundaries. Overall, we'd like to contribute to the main impact that you can see here. Sustainable and circular management and use of natural resources, as well as prevention and removal of pollution, are mainstreamed, unlocking the potential of the bioeconomy, ensuring competitiveness and guaranteeing healthy soil, air, fresh and marine water for all, through better understanding of planetary boundaries, deployment of innovative technologies and other solutions, notably in primary production, forestry and bio-based systems. This comes straight out of the Horizon Europe strategic plan from 2021 to 2024. So finally, what are our nutrients activities about? Our aim is to keep nitrogen and phosphorus flows within safe ecological boundaries, following the planetary boundaries concept that I'm sure all of you are familiar with. And as you can see, we put a few facts by how much the EU is exceeding safe boundaries for nitrogen and phosphorus. that these pollute water, soil, and air, cause biodiversity and ecosystem services loss, present human health risks, and have a quite high cost attached to them. So this is why we decided to get active. And we try to identify certain research and innovation gaps on nutrients and phosphorus that we wanted to focus our work on. So we saw that in some cases there is still basic research needed to fill knowledge gaps of nitrogen and phosphorus thresholds, specifically in flows and concentration in air, water, and soil to protect ecosystems and biodiversity. We thought that it's necessary to model and assess NNP emissions from sources not included in reporting from member states and in consolidated statistics, for example, in Eurostat. Then we wanted to try and stimulate the uptake of technologies recovering NNP fertilizers from waste streams and wastewaters, and assess the environmental impacts of recovered fertilizers, while rendering techniques affordable, reliable, and socially accepted. And finally, we're looking to identify transition pathways to apply integrated nutrient management solutions, including nutrient load targets and ecosystem-friendly practices based on safe regional boundaries and involving all relevant governance levels and actors. So our intervention logic was basically based on 3 pillars: on knowledge gaps, on governance, and on demonstration. In the current work programs, so far we have 2 work programs active in Horizon Europe. We placed these activities in the destination 4 on clean environment and zero pollution, and formulated the following calls. On identifying regional NNP load targets approaches, on optimizing nutrient budgets in agriculture, then assessing environmental impacts of alternative fertilizing products, finding innovative governance solutions to limit NNP emissions in different environments, and in the current work program, best available techniques to recovering or recycling fertilizing products from secondary raw materials, and demonstrating how regions can operate within safe ecological nitrogen and phosphorus boundaries. These are the activities that we have started in the first work program that are continued in the current the work program that is currently being programmed. So this is what we're trying to achieve with our nutrients activities. And finally, just a side glance on the European Green Deal. Of course, we would like our research and innovation on NNP to contribute to the main deliverables of the European Green Deal, specifically the zero pollution ambition and also the integrated nutrient management plan that is inside this ambition, the farm to fork strategy and the biodiversity strategy, as well as the circular economy action plan. Just a few numbers and facts here on which projects have been, which proposals have been successful so far. This one is, these 3 are for the topic on the regional nitrogen and phosphorus load reduction approach. This one on the optimization of nutrient budget in agriculture. Finally, the one on environmental impacts and trade-offs of alternative fertilizing products at global and local scale. And there we don't have, we only have the evaluation of proposals ongoing on the topic of piloting innovative governance solutions to limit NNP emissions at the interface of rural, coastal, and urban industrial environments. To conclude today, I've added a slide on the ongoing projects on nutrient recovery from Horizon 2020, so from our last framework program, where you can see the recently closed projects on water and ongoing on water and organic waste and other related nutrients fields. This is already everything from me. Thank you very much. I'm wishing you a very nice conference end today. And of course, now I'm happy to answer any questions that you might have on our activities. Thank you very much.
So as I said, that brings us to the end. We have announcement about the social activity. Who's going to do it? Come on, a volunteer.
Hi, my name is Henrique. I'm a PhD student here at Boku, and along with my PhD colleagues from RECAP, we would like to invite other PhD students who are willing to do something right now. We're in a very informal setup. We're going to go to maybe a supermarket, grab something to eat, something to drink, sit there, connect, talk, and chill a bit. If you're not a PhD student, obviously you're also welcome to come. We are a very nice bunch, if I do say so myself. And we're going to just gather outside here, up the stairs. So yeah, everyone's invited to come, and I wish you a very happy day and life.
And we wish you the same, and we will wish you it again this evening. Thank you very much. So I think it remains me to thank the organisers, because I am not the organisers. It's not the European Sustainable Phosphorus Platform that organised this. It's Proman Ludwig Herman, who is not with us because he's at the meeting at the Swedish Embassy, being whatever you do at embassies, you know, that's what presidents do. And ETA, who have helped us with the communication, and above all to thank all of you who've put up with 3 days of this. I hope it's been useful for you. The takeaways I bring from this is that I think it's been very useful to bring the research part and the ESPC4 part together in the same place, particularly because it's a rather good place, Vienna. I think we've all appreciated it a lot. That I think has been very positive. That won't happen next year because ESPC, the European Sustainable Phosphorus Conference, happens every 2 years, assuming there isn't another outbreak of major international disease in the next 2 years. But certainly there will be another research meeting, and we're hoping to organise that again with BioRefine, the BioRefine cluster, maybe combining it with their meeting ESNI, maybe in Brussels, maybe elsewhere, so sometime next year. So looking forward to seeing you again there, hopefully at other meetings, workshops on specific things. It's been great seeing you all. I'm afraid I haven't met all of you, and that's a loss to at least me, possibly not to you. But it's been great having you all here. Thank you very much, and let's meet again.